Good morning, students. How are you? Today we will discuss about system of units. As in the previous class, we have discussed about the fundamental units and derived units and the various units characteristics of base and standard units. All things we had discussed. Now today we will discuss about system of units. What are system of units? So first of all, let you know that a system of units are the well collection or a complete set or a complete group of base units and derived units. So the a complete set of base and derived units derived units is called a system of units. It's called a system of units. It means to say that whenever you are talking about a system means to say that a group of things, a complete set of things is called a system. So as we had discussed in the previous class, that units have the fundamental and derived units. Fundamental units are base units or absolute units, and derived units can be derived from fundamental units and base units. So, to define any physical quantity, to give the unit of any physical quantity, we have to take the help of the base units and the fundamental units. Again, here I want to mark one thing, that in various books it is written that base or fundamental units are independent of each other, but nowadays it had been observed that various fundamental units are dependent on other units. Suppose we can say that mass is dependent on temperature, because mass can be varied by increasing temperature or decreasing temperature. So it is not a rightful way to say that the fundamental units or base units are independent. So we are discussing about the system of units. A complete set of base and derived units is called system of units. Complete set of base and derived units is called system of units. Now, the system of units can be further divided into four categories. This system of units system of units can be divided into four categories. This system of unit can be divided into four categories. The first one is the first category of system of units, which was previously used. Beforehand we used this system of unit, that is the Mks system of unit. The Mks system of units. It is called as British engineering system of units. And in this system of unit, the Mks system of unit, in this system of unit, foot is used for measuring length. pound is used for measuring mass and second is used for measuring time. As we had said that in the characteristic of system of units we had studied that the system of unit must be invariant, but here all the physical quantities length, mass and time what is measured in the unit foot, pound and second, it is not invariant. They are going to be varied from person to person and place to place. For example, I want to say that suppose any distance is measured by the help of foot, then the foot length of the foot is different for different persons. So it is not a proper system of unit to be used for our measurement of physical quantities. So the next system of unit, we come through the next system of unit, that is the Cgs system of units. The Cgs system of units. It is also called as Gaussian system of unit. Gaussian system. It is also called as the Gaussian system of unit. And in this system of unit, Gaussian system of unit, centimeter is used for length, gram is used for measurement of mass, and second is used for measurement of time. This is the Cgs system of unit or Gaussian system of unit. In this system of unit, the major drawback is that the units which are used for measuring the physical quantities like length, mass and time are so small that there is the less precise value or less accurate value it is going to give on the measurement. So this system of units are also discarded, and after that the scientists came across a bigger units for the measurement of physical quantities, and we come through the another system of unit, that is Mks system of unit. So the next system of unit is Mks system of unit. The Mks system of units. The Mkss system of units. It uses meter for the measurement of length, kilogram for the measurement of mass, and second for the measurement of time. This Mks system of unit is quite acceptable and good for various physical quantities and quite common also, but the limitation of this Mks system of unit is that this is limited to only three physical quantities, that is length, mass and time, and the various system of various units we are needed for other physical quantities also. So it happened that the group of scientists all over the world gathered together in France, that is Cgs. Cgs is a city in the France where General Conference of Weight and Measures, a laboratory that is called as the where the conference held for the weight and measurement in approximately 1971, and there it was decided some international systems which is quite widely accepted all over the world, and from there the SI system of units came into picture. So next one is the SI system of units, which is widely accepted all over the world. So next one is, fourth one is SI system of units. SI system of units. It is extension of Mkss system, Mkss system of units. General Conference for weights and measures. Cgs, France, in the year 1971. It was the place in France, that is Cgs. There is a laboratory for weight and measures, and where the General Conference for Weight and Measures has been held in the year 1971. And in that place, it was decided the internationally accepted system of units, that is SI system of units. It is called as International System of Units, Systeme Internationale. SI stands for Systeme Internationale. This is the SI system of units. Now, one by one we are going to define the system of units, SI system of units. The SI system of units has 7 base or fundamental units. It has 7 base or fundamental units, and 7 base and fundamental units, and 2 supplementary units. 2 supplementary units. 7 fundamental or base units and 2 supplementary units. The 7 base or fundamental units are meter for length, kilogram for mass, second for time, ampere for current, candela for luminous intensity, Kelvin for temperature, mole for amount of substance. These are the 7 fundamental units or base units, and radian and asteradian are supplementary units. So let us discuss the fundamental units one by one. The first one is the kilogram. First one is kilogram. That is kg. it is the unit of mass. It is the unit of mass. And how it can be defined? The general conference, the meeting held in Cgs for general conference for weights and measures. There it had been decided that the platinum iridium rod placed there, where 90% platinum and 10% iridium cylinder kept in International Bureau of Weights and Measures at Cgs near Paris, France. The mass of that platinum iridium rod, which is placed in International Bureau of Weights and Measures in Cgs, France, is defined as 1 kilogram. It is defined as the mass of a specific platinum iridium alloy in which there is 90% of platinum and 10% of iridium cylinder kept at International Bureau of Weight and Measure at Cgs near Paris, France. Why platinum iridium is used? Till now, this is the well defined. There is no change in the definition of kilogram, and platinum iridium is used here because platinum iridium is a stable platinum iridium is a stable alloy. It is a stable alloy, so it is used as the material for defining 1 kilogram mass of 1 kilogram. Now the second one is unit of length. Second is meter. This is the unit of length that is called meter, and it is the unit of length. It is the unit of length. It is the SI unit of length, the standard international unit of length. Before 1960, it was defined that distance between two lines of a specific platinum iridium bar stored under controlled condition. That distance between the platinum iridium rod, in 1960 it was said that the distance or length of platinum iridium rod which is kept in Cgs, France, is considered as 1 meter. But that was not satisfied the conditions for the system of units. That is, it is neither invariant nor precise also. It is not precise also, so it is not adopted further for the system of units. So after that, it was defined that the meter, 1 meter is the meter of length in that case it was defined that 1 meter is the length equal to a specific number of wavelengths. In terms of wavelengths, it had been defined 650,763.73 number of wavelengths in vacuum of a specified radiation corresponding to transition between the levels 2p10 and 5d5 of krypton 86 atom of krypton 86 atom. Means since it was the length at 1960 it was defined, before 1960 for defining meter it was said that the distance between two lines on a specific platinum iridium rod was accepted as. So since it is not easily available and it was not reproducible also, because it is not possible for everyone to go through France and see that distance. So after that, in 1960 it was defined that 1 meter is the length equal to the transition of transition of wavelength in vacuum of a specified radiation of krypton 86 atom from which orbital, from 2p10 to 25d5 orbital, whatever the transitions is going on, and during this transition whatever the radiations are emitting for krypton 86 atom, the length of this much time, the number of the wavelength of itna transition, that much transition, whatever the wavelength of light for this much of transition is called as 1 meter. But all things in this is right, it is reproducible, but accuracy is the problem in this case. In this case also, while defining in 1960 it was defined like the transition in krypton atom, and the accuracy was the basic problem. So finally, in 17th General Conference on Weight and Measures, 17th General Conference for Weights and Measures, which was in 1983, the definition of meter is redefined. The definition of meter, 1 meter, the definition of 1 meter is redefined, and it was said that the meter is the length of path. The meter is the length of path traveled by light in vacuum, during a time interval of 1/299799245 of a second. This is nothing, this is only, you can write here also as 3 into 10 to, it is approximately equal to 3 into 10 to the power 8. 3 into 10 to the power, it is approximately, it can be assumed like this. So 1 meter is the length of path traveled by light in vacuum during a time interval, during the time interval 1/3 3 into 10 to the power 6 of a second. So suppose we are saying that 3 into the speed of light. If I am telling by speed of light, that is equal to 3 into 10 to the power 8 meter per second. So 3 into 10 to the power 8 meter per second means in 1 second the distance is traveled by 1 second. The distance is traveled by the light is 3 into 10 to the power 8 meter. 3 into 10 to the power 8 meter. Then if you have to find what is the distance of 1 meter, then for finding the distance of 1 meter you have to divide 1 by 3 into 10 to the power 8. That will be the length of 1 meter, and in this way, in that conference it was decided that this will be the proper definition which is widely accepted, and there is no variation till now in the definition of the meter or the SI unit of length. After that, there is the time. The third one is second. Second. It is the unit of time. It is the unit of. It is the unit of time. Before 1960. Before 1960. Before 1960, the time before 1960, the time is defined in terms of solar day. The time is defined in terms of solar day. And what is solar day? Solar day is nothing. Solar day is the time interval between successive appearance of sun overhead. When means if the sun is at your overhead, then the next time when the sun become over your head, then whatever the time is called as the solar day. So second is defined in terms of solar day, and 1 second can be said as 86400 of mean solar day. Solar day. Solar day is what? Solar day. Time interval between successive appearance of the sun overhead. Successive appearance of sun, that is equal to solar day. So 1 second is equal to 1/86,400 of mean solar day. And this definition was not widely accepted because the solar day varies due to the change of seasons, due to high tides or low tides and various other geographical factors which are responsible for the change of day. So it was not widely accepted. This definition or this way of defining the second is not widely accepted. So in 1967, there was the meeting of General Conference of Weight and Measures, and there it was redefined. The definition was redefined on the account that the previous definition was not so much precise. So there was the concept of atomic clock came into picture, and on the basis of atomic clock, there was the next definition in 1967. The next definition of second came into picture, and how it has defined. in 1967. Basis was atomic clock, and it was defined as a second is defined as the time interval occupied by 192.631.770 cycles of specified energy changes in the Cesium 133 atom. That much time interval in which the time interval which is required for the transition of energy or for the transition of electrons from higher energy level to lower and lower energy level to higher energy level, when certain energy is supplied to it, if that transition becomes 9192631.770, whatever the time required for this cycle to complete in a Cesium 133 atom, that time is considered as 1 second. So 1 second, the time taken by exactly 9192631.770 cycles of a certain wavelengths of light to be emitted by cesium atom. The time taken by exactly itna cycles, itna transitions, cycles means transitions of certain wavelength of light emitted by cesium atom from higher to lower and lower to higher energy levels. Whatever the time required for this much amount of transition in a cesium atom, that time is defined as 1 second, and it is widely accepted. Now the next one is ampere, that is the SI unit of current. Next one is ampere. Fourth one, that is called as ampere. It is very simple to define ampere. In class 12th you will study whatever the definition I am giving here about the ampere. The same derivation you have required to do in class 12th also. That is, when two wires are separated by a certain distance, and if the current is flowing in, if suppose two wires are separated by a certain distance, then if current are flowing in both the wires, then there is a force of attraction and repulsion between the force of attraction or repulsion between the two wires, and the force, if the force is equal to 2 into 10 to the power, whatever the force of repulsion between two wires, if this force is of 2 into 10 to the power minus 7 Newton, if that much amount of force is experienced by these wires, then the amount of current whatever flowing in these two wires, that current is called as 1 ampere. So there is a derivation regarding this thing in class 12th. So let us define 1 ampere. It is unit of electric, it is unit of electric current. And how it is defined? It is defined as that constant current which, if maintained in two straight parallel conductors of infinite length and of negligible cross sectional area placed 1 meter apart in vacuum and causes each to exert a force of 2 into 10 to the power minus 7 Newton. That much amount of force is experienced by that much amount of force is experienced between two straight parallel infinite rods which are placed 1 meter apart, then that the current flowing in the wire is called as 1 ampere of current. Next one is candela. Luminous intensity, that is fifth one, and this is candela. SI unit of luminous intensity. And how it is defined? The SI unit of luminous intensity can be defined as that the particular monochromatic radiation having particular frequency of 540 into 10 to the power 12 Hertz has a radiant intensity in that direction 1 upon 683 watt per steradian. Per steradian means a particular, in any solid a particular solid angle is considered, and that on that solid angle 1 upon 683 watt per steradian, if energy is radiant by a light of frequency 540 into 10 to the power 12 Hertz in a particular direction, then that is called as the 1 candela. So note it down. The candela is the luminous intensity intensity in a given direction, of a source that emits monochromatic monochromatic means to say that having single wavelength or single frequency, having particular frequency, monochromatic radiation of frequency 540 into 10 to the power 12 Hertz and has a radiant intensity in that direction of 1/683 watt per steradian. Suppose this is a solid body. Solid means, since it is two-dimensional, solid means a football, just like a football. A watermelon is the solid body. And if any source is placed here and it radiates the power of that much amount for per steradian, this is the solid angle, per steradian, and if that radiant, the frequency of the light is 540 into 10 to the power 12 Hz. If that source is radiating the light having the frequency 540 into 10 to the power 12 Hz, and it delivers a power of 1/683 watt per steady pulse per solid angle, then whatever the intensity of light falling on the surface of the solid is called as 1 candela. Next one is Kelvin, that is the temperature. Kelvin. It is the SI unit of temperature. It is the SI unit of temperature. All of you had heard this unit, that is SI unit of temperature is Kelvin, and it is defined as in terms of triple point of water. That is the fraction 1/273.16 of the thermodynamic temperature of the triple point of water, Triple point of water is that temperature at which all the three phases, solid, liquid or gaseous phase of any liquid coexist, is called triple point of water. And that there is the thermodynamic temperature, any temperature, so 1/273.16 part of that temperature is called as 1 Kelvin. Means the temperature where the triple point of water exists, the 1/273.16 part of that temperature is considered as 1 Kelvin, and it is the SI unit of temperature. Now the last SI unit, that is mole. Mole, amount of substance. This is the SI unit for amount of substance. SI unit for amount of substance. It is SI unit for amount of substance, and it is the defined in terms of carbon C12. The amount of elementary entities present in 0.012 kg of carbon C12 isotope, that amount is called as 1 mole. Means 0.012 kg of carbon C12 is taken, and what much of carbon C12 is present in that mass of C12, that entities are called as 1 mole. So note it down. The amount of substance, the amount of substance of a system which contains as many elementary entities called as atom, molecules, whatever it may be, entities, as there are atoms in 0.012 kg of C12. 1 mole is equal to 6.022137 into 10 to the power 23 a specific elementary means that much elementary entity. Means the SI unit, this is the SI unit of amount of substance, and the amount of substance of system which contains as much elementary entity means this much kilogram of carbon C12 isotope, as much atoms it consists, that atoms is considered, that much number of atoms is considered as 1 mole. And obviously it is observed that 6.02137 into 10 to the power 23 atoms are present in C12 isotope of that mass, and it is considered as 1. So for today, that's all, students. For in tomorrow lecture, we will discuss about the supplementary units, that is radian and steradian, and after that we will discuss about measurement of mass, measurement of time, measurement of length. All things we will discuss in later sections. Thank you, students. Have a good day. Thanks.